Okay, good morning everyone. I think I can start the class now. Let me remind you some homework this week. We have Tower 1 and Tower 2 due on this week, and we have interactive review from Tower 1 to Tower 3, and we have one more heading homework due next this week, heading homework 7. Maybe on, let me see, okay, on Friday this week, on handling homework 7. That's all the things about this. The handling homework 7 is the final handling homework in this semester. I will not give you any assignment for the handling homework. Yeah. Okay, that's all the things about this. And I will let you know about the information about the final exam soon. Maybe this week, at the end of this week. Any questions so far about this? Okay. Because now I will move on to the chapter 12, which is the final chapter in this course about the scatter plots and correlations. And it's talk about a regression also. And in this chapter, we will talk about the relationship between two characteristics. Okay. When we analyze two characteristics in the populations, it's better for us to know the relationship between them. So how do we know this? Sometimes we know the relationship between two characteristics by using the graph. Okay, by using the graph. We have two axes like this, something that we have the two axes. This is what a variable 1, and this is a variable 2. Sometimes we know this, like we have some information about this, like this. Okay, okay, we have the graph like this, so we have the relationship between them. For example, the variable 1 may be the number, the day, okay, the day, and the variable 2 may be the number of cases of COVID-19, something like this. So we have two variables here, and the number of cases of COVID-19 will depend on the day. This is a variable 1. Okay. So if we know the relationship between two variables, through the graph, we can predict the future. We can predict the not just a few days in the future. We can predict the patterns. We can read the pattern of them, and we can know which cases will be increase or decrease, something like this. And that's either the rows of the graph or the scatter plots here. Okay, that's the introduction about this. So now we move on to what is scatter plot here and what is correlation. Okay, and this the goal for today here, we will construct and interpret the scatter plots, and we will calculate and interpret the correlation between two variables. The objective. Okay, that's the definition. A scatter plot is graph on a coordinate plane that contains one point for each pair of data. Okay, the horizontal here is the x-axis. The x-axis here. X-axis. And here is the y-axis. What the x-axis represents for the explanatory variables. And the y-axis represent for the response variables. So you have learned about the explanatory variable and response variable in chapter 2. Okay, so what about this? So I will call you what is the response variables and what is the explanatory variable. The explanatory variable, okay, this is a y-axis, right? The y-axis is the response variable, right? And this is explanatory variable. The response variable will be depends on the explanatory variable. That means that the explanatory variable will affect the response variable. This is the response and explanatory variables. Okay. Okay. So we have two variable here. So the explanatory variable influences a change in the value of the variable called the response variables. So in this code we just consider the case in the population we have just two variables. Maybe in the higher courses you will consider two or more than two variables, maybe three, maybe four, something like this. But in this course we just focus on the population having two variables. So it's easy for consider. Okay. So the importance of scatter plot is that it enables us to identify the change of the data. Okay, we will know the change of the data. When we know the change of the data, we can predict the number of data in the future, something like this. Okay, for example, do the points fall in the linear patterns or the curve pattern or no pattern at all, something like that. For example, when we get some point here, for example, maybe this is 2000, 4000, not something like this. 6000 is the number of cases right here. And this is day, something like this. It's the 1, 2, 3, 4, 5, something. So this is the day 1 is 2000, day 2 4000, 4000 here, and something like this, something like this, something like this. So we can guess the change here. Maybe it's like the line here. So we can guess the day 6 should be like around the value like this or like this, something like this. If we know the change of the data, we can draw the graph for this. And when we have the graph for this, we can guess the number of cases in the future, something like that. Sometimes the data, not the line, sometimes it's like this. Sometimes it's like this. Okay, so we can guess it is a curve. Okay. And in this course, we just focus on the data have a linear set. That means it have the line set here. Okay. Sometimes we call it linear regression. Okay. Okay. So I will give you some example to draw the picture to make the practice how to plot the data. To plot data in the graph. Okay. I will consider the table 2 is sample of water packs. Okay. And we have the number of passing here and salary here and the rating here. Okay, and we have some people here. And this is the table. And the question here is they ask us to use the data from this table to produce a scatter plot that shows the relationship between the base salary. Okay, we have to know which is one. The base salary and the number of touchdown, right? Touchdown. Okay, so we will look at the table again. Okay, so we have the number of touchdown here and we have the salary here. We have two variables here. So now we will we will construct the scatter plot here by using the graph here. Okay, so we will draw the picture first. Okay, number of passing touchdown. Oh, sorry. Okay, I will write down here is the number of touchdown. This is the expenses and the salary here. Okay, a number of passing sit down, we will look at the minimum value and maximum value. So in this column, we see the maximum value 46, right? And we look at here is the minimum value 12. So we can choose this one in 10, right? 10. And maximum value 46, so we choose 20, 30, 40, and 50. Okay. Here. What's that? Okay, this is the number of touchdowns. And what about salary? What about salary? So we look at what is the maximum value here. The maximum value here is 12.5, right? 12.5. And the minimum value here is 0, right? 0.95. Okay. So I will see 1, see the 12, right? So I use this in 4, 7, 10. This is 13, something like this. It is okay. So now we will put on the graph here. Okay, for the first one is 46 and 3. 46 and 3. So you see 46 may be here, right? And 3 may be here. Okay, so put it like this. Okay, is it clear? Let's see the first one. It's 46 here and it's 3 here. So I put 46 is represent for 46 and 3. Okay. What about the second one? It's 18 and 12.5, right? 18. So we look at here. 18. So it should be like this. And 3 here. 3 here like this, right? No. 18 and 12.5. Okay, 12.5 so maybe here. Okay, this is the second one. Okay. And 27, 10.2. 27 may be here. And 10.2, right? 10.2 like this. So I put this here. Okay, this is the first one. And 31, 0.825. 31, so here. So this value here like this. 31. And this value here. Okay. And 45, 8. 45 here and 8 here. Okay, we have this value here. And 13, 7.7. 13, so this should be like this here. And 7.7 here. Okay, we have some value. And 17 and 5. 17 and 5. Okay, so it's like this. Okay. Is it clear, guys? That's the way to make the plot for this. Okay. You can look at this picture like this. Okay, we have some variable, some they put on this. But the question here is, looking at the scatter plot here, we do not see any the linear portion. We cannot find any the line go through this point, right? Sometimes we don't have any relationship between them, right? We don't have any relationship and no portion is evident. Okay. This property indicates that these two variables do not have any relationship. Okay. So what about, let's see the relationship between base salary and the number of touchdowns. We don't have any relationship here. If we look at the graph like this. Okay. So the example 2 here is use the data in the table 12.2 to produce a scatter plot that shows the relationship between the number of touchdowns in one season and the corresponding quarterback. Okay, we have 2. So now we don't care about this. we will move on to another variable. What is it? It's either number of touchdowns, right? And this one here is the quarterback rating. Okay, so we look at the table again. We look at the table again. We have two variables now. Here is the number of touchdowns. This is the first one, and this is quarterback rating is the third one. And you do similarly like me. You can draw the graph for us, and the graph should be like here. Graph like here. Okay, you can see that this is the number of passing touchdowns, and this is the quarterback rating. And in this case, so we can see that we can see the line. We can see there is line will touch this point. So in this case, we call this data have the linear patterns. Okay, because we will have the line go through these T points, not go through all the points, but it will have the line go through near all the points, and all the point is close to this line, close to this line. Not this line go through all this point, but we have the line go close to this point. Okay, go close to this point. So in this case, we call this it have the linear patterns. Linear patterns. Okay, that is the scatter plots and linear patterns. Okay, notice that the points tend to go up from the left to right and fall close to a straight line. This pattern can be described as a linear pattern with a positive slope. Okay, what does it mean? What the positive slope here? We have two kinds of data. So this data like this, we call positive slope. And this data like this, called negative slope. This one. This is positive slope and this is the negative slope, so you can look at the slide here. Okay, this is okay. So now we will move on to the example here. So in this example, so you will guess relationship between them. Determine whether the point in the scatter plot for the two variables are likely to have the positive slope, negative slope, or not follow straight line pattern. Okay, so you can look at the example. Okay, the positive slope, that means that this will increase, right? This will increase, and the negative slope this will decrease. Okay. What about A? The number of hours you study for an exam and the score you make on that exam. So what do you think? Do you think it's either positive slope or the negative slope? Okay, lift please. Positive slope. Okay, thank you. Right, exactly. This is the number of hours you study, right? And this is the grade. This means if you spend your time, if you will spend a lot of time doing doing your homework, doing the exercise, something like this, so you will get the highest score, especially in my course. Okay, if you spend your time doing my homework, doing your online homework, so you will get the highest score. No problem for this. This is the linear patterns, and it has the positive slope. What about B? The price of used car and the number of miles on the meter. Okay, can simply?
Negative.
It's negative, right? Exactly. When you use a car in the day, so maybe it will be right. This is right here, and when you use a long time, so the price will decrease. This is the negative slope. Okay, thank you. Okay, I forgot here. Okay. Okay, so now we move on to see the pressure on a gas pedal and the speed of the car. What do you think? Okay, you please. Okay. A positive slope, okay? Okay, exactly. And the suicide and IQ for those? Okay, Xavier? Okay, why you choose positive? Suicide and IQ for those IQs. IQ for those. Is there any relationship between them? The suicide and the IQs of the person? No, nothing, right? We don't have any relationship between them. The suicide doesn't relate to the IQ of a person, right? So in this case, we don't have any relationship between the suicide and IQ for those. So we choose this. It did not follow a straight line path. Maybe it will follow a curve, something like that, but we don't know that about it. Okay, so we have some kind of data. We have strong linear relationship if all the point here is very close to the line, very close to the line. So we call it strong linear relationship. Okay, if you look at this one, this is weak linear relationship. This means that the point here will not close to the line. So we call it a weak linear. Okay, weak linear relationship. And in this case, we don't have any information. We don't have any relationship, so we have no linear relationship. Okay, no relationship. But in this case, the final case, so you see that it has the relationship like the curve, right? Like the curve. So in this case, we call it a non-linear relationship, because it has the channel like the curve, okay? Like the parabol here. Parabol here. So you know this. You will know that if you study the course about the elementary functions, maybe you know this. It has the curve, the channel like curve. Okay? So it's called a non-linear relationship. Okay, this is some kind of data. Okay. And now we move on to the final one of this section today. That is the Pearson correlation coefficients. Okay, what does it mean? That is the parameter that measures the strength of the linear relationship between two quantitative variables in the populations. Okay, and the coefficient here is from between -1 to 1, right? And if okay, so what does it mean? If R is positive, then the scatter plot has a positive slope. Okay, if R is greater than 0, so we have the positive likeness. If R is less than 0, so we have a positive likeness. Okay? And if R is 0, we don't have any linear relationship between them. If R is 0 or close to 0, then no linear relationship between them. Right? Okay. And if the R is greater than, if this one is close to 1, it's very close to 1. So this means that we will have the strong linear relationship. Okay. If R is close to 0, we don't have any linear relationship here. Okay. Okay, we have the summary for this. If R is -1, so we have the strong linear relationship. If R equals 1, we have the positive linear relationship. If R equals 0 or close to 0, we don't have any linear relationship here. Okay, so we have some picture for this. So here you can see this correlation is 0, so we don't have any information for this. The correlation is -0.3. We also don't have any relationship for this because it's close to 0. It's similar to 0.5. This one, where is 0 is R here is -0.7. This is close to 1. So we see that it has the line here. This is weak linear, right? This weak linear. When R is 0.9, so we see that we have the line close to this point, so this one will be strong linear, right? And when the R here is negative 0.999, so we can see we will have perfect linear approximation, right? We have linear pattern here. If this point is close to negative 1 or 1. So we have some correlation here. So the question here is, how do we calculate it? How do we calculate the correlation here? How do we calculate this? This is the question. How do we calculate this? So we will calculate this by using this formula. Okay, you can see this formula very complicated. Okay, so you can choose to calculate it by your hand by writing every variable here. So and you can apply this formula. But sometimes it is very hard to do this. It is easy to make mistake when you do this. So now I will introduce to you how to calculate this by using the Excel. How to calculate it by using the Excel. You can do this by your hand. So for example here, we have two ways to do this. We can apply the above formula and we will get the result here 0.9941. So it is a strong linear relationship. Otherwise, you can use Excel. Okay, how to do this? Okay, I will show you how to use Excel to calculate the correlation. How to calculate this? First one. Okay, can you see the screen? Okay, I put this small, this greater. Can you see it? Right? You see it, right? Okay, I will put everything, every data, put the data to the Excel. Okay, and you can see we have X here is the firmness and humerus here is Y. So I put X here like this, and we put Y here is this, right? Okay. This one is X1, X2, X2. X1 is 38, X2 is 56, X3 is 59, something like this. This is I1, Y1, Y2. We can apply this formula, right? We can apply this formula. Otherwise, you can use the correlation here. How to do this? We will use the equal column, right? And okay, you can see in the picture, so like it's asked you array 1, array 2, right? So array 1, you will choose this row, right? And after that you comma here, okay, comma, and choose the second bar. Okay, enter. So you will have this one. This is the correlation. Okay, is it clear? That is the way to calculate the correlation. And you can see this. You can see this. This value is close to 1. It's close to 1. So it's a very strong linear relationship. Okay? If you draw the picture for this, so you will see this is a line like this. It will have a line like this. Okay, I will draw the picture for this. So here X here and Y here. This is 38. Right? Okay, I will put the picture for this. Okay, so X here. Okay, I will choose it. 30. Okay, 40, 50, 60. Okay, 70. 80. This one I will choose is the okay 41, right? 41, so I will choose 30, 40, 50, 60, right? Okay, like this. What about 38, 41? 38, 41, so I will choose this one. And 36, 63. 36, 63. So it should be like this. And 56, 70. Okay, like this. And 64, 72. 64, 72. Like this. And you can see this is the line. Okay? This will have a strong linear approximation or strong linear patterns. Okay? We just check about this. Okay? So now we move on to some practice exercise. Any questions so far about this? So this is just section text. It's not difficult at all. So we have some data. Complete the following objects for each data set. Draw the scatter plot, estimate the correlation in works that is positive, negative, or no correlation. Okay, and calculate the correlation coefficients. How to do this? I will do the question 1. It's 13. We have two graph like this. Okay, it's a number. Okay, this here is X, right? The front here is dollar and Y here. So X here is 7, 18. So you choose 1 to 20, right? 1 to 20. So 2, 4, 5, 6. 8, 10, 12, 14, 15, 18, 20. This is the X here. And what the Y is price, right? Price here is from, let you see, as you can see is maybe the maximum value is 200, right? Is 20, right? Okay. So I will choose the value from 20 to 200. 20, 40, 60, 80, 100, maybe greater than here. The top is enough space. Okay, this is enough space for this. And now we will put everything on the graph here. Okay, 7, 106. 7, 106. So I will show here is a value. Okay, is it clear how to do this? What about 18, 100, right? 18, 100. So it should be like this. Okay. This one. Okay. 32. 32. 32. Oh, okay. So it's very long, right? 32. It is. My God. Maybe I need to. Okay. Maybe I will change it. It's very long. I will. I see. So I will not do like this. 32. So I will choose is 3, 6, 9. This one is enough. It's not enough. 4, 4, 8, 12, 15, 20, 24, 24 and 28, 32, okay, and 36, something like this. Okay, so now it's enough here. 7 and 106, right? 7, 106, so here. This is the first one. And 18, 100. 18, 100, so it should be like here. 18, 100 should be like here. And 32, 32 here. And this is 129, so it should be like here. Okay, and 11 here. Let's see, 17. Like this. Okay, 20, 200. So you can guess this. So you can guess it. It has no relationship, right, at all. Okay. If you draw some value here, okay, you can get this. What about this? So you can do it by yourself. Draw the all picture for this. This will have some kind of problem in your online homework. Okay. And the second one, we here will estimate the correlation in works that is positive, negative, or no correlation. Okay, could you tell me that is positive, negative, or no correlation? Is it no correlation, right? Okay. And the final one is we calculate the correlation coefficients. How to do this? Okay. Similarly, you will put everything to this one. Okay. I will show you how to do this. Okay. It's 7. Actually 7. 18. Let me see. 32. Okay, let me use the book. This is better. Let me use it. Okay, I will use the book here. 32, 11, 20, 1, 5, 4, 2, 1. Okay, and price here 106, right? 100, 129.99, 76, 200, 25, 22, 20.5, 36, 36.5, and 49.99. Okay, so it's better for you to use Excel to calculate the correlation here. So we call correlation. Okay, and I will choose the X here, first row, and after that comma to the second one. Okay, after that. Okay, so you see that this is 0.69304. So this is not close to 1. So we don't have a linear relationship here. Okay? This is easy for you to use Excel to practice. Okay? So try to do it by yourself. Okay, using the table. It is better to use the Excel than you calculate by your hand. Draw everything and apply this formula. So this is very hard. If the data we have 1,000 number, we have 1,000 value, 10,000 value, you cannot do it. You only use the table by itself to calculate this. Okay? You cannot do it. When we do the survey, like the number of students at West State University have GPA, something like this, you cannot calculate by your hand because the value here is very large, right? The number of students is very large. So you will only have put everything on the table, put everything on the Excel. After that, you will use this one to calculate it. You cannot do it by your hand. Okay? Any questions so far? Okay. I think you can do this homework by yourself. It's not difficult. It's 14, 15, 16, 17, 18 by using the Excel. It's not the handing homework. It's not assignment here. It's just practice exercise. Okay. We will not have any handing homework in this chapter. Okay. I will get you some kind of practice exercise. Okay. You need to do this to understand the material here. In this chapter, it's not difficult. The final chapter is not difficult for you. And on Wednesday, we will finish this chapter. And after that, I will review. Okay, I will review for the final exam. And the final exam we take on the Friday, April 10. Okay, question? Have question? Okay. Question.
Is it online, the final exam?
Yeah, online. You do at home like the first exam, second exam like this. We got exam 4 on April 22 to 25. I will give you the choice on that day. 25 to 20, 22 to 25, you can do any time from 22 to 25 for the exam 4. Exam 4 will cover chapter 10 and chapter 12. Not difficult. And try to do your best. And I will summarize the bonus point soon, and I will give you the bonus point to the test. The first exam, the second exam, maybe third exam. Okay, I will summarize. This will be beneficial for you. I will try my best. But the final exam, I cannot do anything. I cannot control this exam. I cannot do anything. Okay, so that will finish today, and I will make the attendance here. Any questions so far about the material in class? Okay. Samia here, Max here, Hannah, Laurel, Xavier here, Kylie, Fabi, Christopher Dollars, Lee, Mackenzie, Robin, Bennett Rossinger, Abdul Hamid, Elizabeth here.
James couldn't make it today, so we have to
James?
Yeah.
Oh, yeah, he had to write email to me.
Alright.
Okay, let me. If he email to me, so I will make attendance. John Peters, Kipling, Lee here, Delaney, Madeline, Ardelia, Alondra, Matu, Wick here, Tyler here, and Aliyah Smith, Yasi, Sullivan, Maria, Thomas, Ria, Thomas or no? Okay, Arthur. Thank you for your attention. Have a good day. Okay, thank you. Thomas?
Yes.
Okay. Not time, I'm sorry. Thomas. Okay.
I didn't take the exam 3. Did you get my email?
You ready to take exam 3?
No.
You didn't email to me, right?
No, I didn't. Did you get it?
No, I didn't. I didn't respond to you, right?
Huh? No.
Maybe I didn't receive your email. This today or the last time?
The last time. It was on Saturday, the internet Wi-Fi, and Wednesday was yesterday.
Let me see your email.